Hello my dear students, welcome to the MS Science Academy. Myself Meenu Srivastav, and today we are going to discuss about the Friedel Craft reaction. The Friedel Craft reaction is the Friedel Craft reaction. It is of the two type. One, the Friedel Craft alkylation, and second, Friedel Craft acylation. Okay, so in the Friedel Craft alkylation, the alkyl group will attached. Alkyl group means the methyl group, the ethyl group, or in the chemistry you can represent it by the R. But in the acylation, the acyl group means the RC double bond O group will attack. R may be CH3, CH2, CH2, like that you can add. So see, in the acylation, this acyl group like that, groups you can add. Okay, so we will discuss about the in this lecture we will discuss about the Friedel Craft alkylation. First we will see the overall reaction of the Friedel Craft. This is first the alkyl halide, means suppose that if we are taking this is the methyl halide, this in the presence of anhydrous AlCl3. Anhydrous means they are not having the water. Okay, AlCl3, ZnCl2, whatever Lewis acids you are taking. So in this step, this benzene, this halide group will this alkyl group will attached. And this HCl, HX, not HCl here, not I am representing here Cl. So HX group will released. Okay, so first we will see the step 1, the formation of the generation of electrophile generation. So in this step the electrophile is generated, and how it's possible? Suppose that CH3Cl and the AlCl3, this AlCl4 negative and the CH3, this is the carbocation is formed. Okay, like this. But in the second step, the formation of sigma complex formation step. So in this step, what will happen? The benzene ring is attacked by this carbocation, either it's a methyl carbocation, it's a ethyl carbocation, whatever, it depends on the R group which we are taking in the initial. Okay, so this benzene ring is attacked by methyl group, methyl carbocation. Okay, so here the positive charge is here, and the second step this, and this positive charge is continuously rotating on the ring like this manner, as we have discussed earlier also. The complete resonance hybrid is like that. Okay, but here in the resonance hybrid, this is the resonance hybrid or the sigma complex is formed. So in the third step, this proton elimination take place. So in the third step, the proton elimination. So in this step, this, okay, so what will happen in the presence of AlCl4 negative, and what will happen here? This methyl group remain attached, and this hydrogen is attached with the extra chlorine which is attached with the AlCl4 negative, and this HCl is released, and the AlCl4 is released as a AlCl3. So this is overall here in this reaction. First the electrophile is generated, which is the carbocation, and in the second step the sigma complex is formed, in which the methyl or the carbocation is attached, remain attached, and they generate the positive charge on the ring. And in the third step the proton is eliminated with the help of AlCl4, and in the extra chlorine is released as with the hydrogen as HCl and the AlCl3. Okay, this is the complete methyl benzene, and we can say it's a toluene. Okay, this is the overall reaction. Now we will see the limitation of the Friedel Craft alkylation. Let's see. Now come to the last part, that is the limitation of the Friedel Craft alkylation. The Friedel Craft alkylation has some drawbacks which are we will discuss. Here the first is the rearrangement of alkyl group. As we have discussed in the Friedel Craft alkylation, that the main attacking species, that is the carbocation. Like that, the carbocation is CH3 plus, CH3CH2 plus, and CH3 CH2 CH2 plus. Like that, carbocations is acting as a attacking group. Now, if the main thing is that if the benzene ring is attacking with the one or two carbocation, one carbon containing carbocation, it is having no issue. If it is having if the carbocation is having the 2 carbon, it is having no issue. But the main issue generated from the 3 carbon, as when the 3 carbon, this is the N-propyl carbocation. So when this N-propyl carbocation is attacking on the benzene ring, this carbocation will just going towards the rearrangement, and this N-propyl carbocation just converted into the isopropyl carbocation. Okay, so if you want to get the product of N-propyl benzene, so this product yield is very less, because the carbocation goes towards the rearrangement. So the main product is isopropyl benzene. So this is the main thing, is that whatever product you want, but if the carbocation is going towards the rearrangement, that's the main critical condition to getting that exact product. Okay, so this is the main limitation. Second is the polyalkylation. Suppose that the introduction of an alkyl group in benzene activate the ring for further electrophilic substitution. Here, if we are just introducing one methyl group or the alkyl group, so what happen? This ring become more susceptible for the further alkylation. So if we want to get the toluene, so the reaction will not stop here. The reaction will goes towards the ortho and para-xylene formation, because the reaction will because the toluene will get more susceptible to accept the more alkyl group. So the main product will not form the toluene. The main product is the ortho and para-xylene. So if we want to take the toluene, so if we want to make the toluene, we have to keep in your mind that the methyl chloride and the AlCl3, you have to take very less quantity. So the reaction will stop here. Otherwise, if you are taking the CH3Cl and AlCl3 in slight more, then the reaction proceed further. Now, the third limitation is that the hindrance of the meta group. What is the meta group? In the next video, in the next topic, that is the substituent effect, like that topic, we will see that there are the 2 type of the groups. One is the ortho para directing and second is the meta directing. In the meta directing, the example is nitro group. So suppose that if the nitro group is attached, what happen? If the nitro group is attached, as the nitro group is the meta directing, so this meta directing group is not allowed the alkyl group, so what happen? The nitro group is not proceed the Friedel Craft alkylation. FC means the Friedel Craft alkylation, because the Friedel Craft alkylation is the ortho para directing reaction, whereas the meta directing reaction is just want to push the reaction towards the meta direction, but the methyl group attachment or the Friedel Craft reaction is the ortho para-directing reaction. So it's just we can say they are just opposing each other. So the nitrobenzene cannot proceed for the further alkylation. So if we want to introduce the alkyl group in the meta directing group, it's a quite impossible, or we can say we have to maintain the other circumstances or the condition for proceeding the reaction. So this is the main drawback or the limitation for the Friedel Craft alkylation. I hope you have enjoyed my lecture. Any doubt, kindly ask in the comment section. Otherwise, please like, share and subscribe. Thank you.